Cool. Hi, everyone. Thanks for joining. Just as a heads up, I'm going to talk about a technology in here called RisingWave. I actually asked someone from RisingWave to come into the session to answer any questions in the chat. If you have any questions during the session, feel free to ask in the chat. His name is Zach. And also after the session too, he might chime in on some things as well. I'm going to start. I'm going to dig into this a little bit. So this is about real-time and historical NLP enriched market dashboard with RisingWave and Chat-GPT. Unfortunately, the demo is not working right now. So I took screenshots of the code to be able to show you guys and images of what the app looked like. It was a React app that was built out, but it's not functional right now. So unfortunately, we're going to have to do with screenshots, but hopefully it'll still be informative. Okay. So sorry about this. I have to skip back and forth between screens in order to be able to, get my speaker notes and everything. So first, we're going to talk about the benefits of generative AI on streaming data. I also, just because I know that there's people from all over the world joining, I added all my speaker notes in here so you can actually read along as well. It's not generally common practice to do this when you're presenting, but I did this just to make it easier for everyone and also to be able to share the slides after the fact as well. Okay, so first of all is generative AI, which I'm sure some of you guys are familiar. It's a type of artificial intelligence that creates new data. And then streaming analytics is the process of analyzing the data as it's being generated. So new data comes in and then you're doing some kind of an analysis or transformation on the data as it comes in. So the benefits of using processing data, generative AI on streaming data is you have the ability to generate synthetic data for training and testing machine learning models. You can identify anomalies in streaming data, and then you can also forecast future events. I'm wondering if this slide showed, right? Oops. Okay. So I'm going to talk a little bit about RisingWave. I think I'm wondering if I'm just making sure I'm on the right screen. Sorry, I have to jump back and forth between stuff. Okay, so if you haven't heard of RisingWave, I'm not sure if any of you guys have. RisingWave is a distributed SQL stream processing database. So essentially, it's designed. I can kind of give you the overall understanding. I'll dig into it a little bit more about what it's kind of used for, but it's designed to reduce the complexity and cost of building real-time applications. It consumes streaming data, performs incremental computations on the data as it's being ingested, and it updates the results dynamically. And then it also maintains the results on its own storage. So as I mentioned, it's a database. So then you have the ability to access the data effectively as well. So what is stream processing? I'm assuming that some of you guys may or may not be familiar with stream processing as a concept. So stream processing is basically when it's a data processing approach that deals with continuously flowing data. So event happens, a user clicks on something, whatever, that data is ingested, and then that's a streaming, but it's consistently being ingested versus something like batch that, is just done every so often, every hour or whatever. So stream processing also involves real-time analysis, transformation and computation of the data as it arrives without the need to store it in a traditional database. So literally, it's you are, as your data is being ingested, you have the ability to take actions on that data, transform it, analyze it before it hits storage. And then, you have the ability to then store it and then make it available for future use, or you can even bring it back into another stream, just looping it around. And it's used to extract valuable insights, detect anomalies, and then trigger actions based on incoming data. I will go over a little bit about the capabilities of what you can do with stream processing inside of your streaming data. Okay. Understanding stream processes. So there's a few different, basically you are pulling in data as it happens. These events are being ingested, and then you have the ability to analyze them, or do any kind of queries or transformation on this data as it's being ingested before it's being stored. So some of the different types of things that you can do in terms of like the transformation and analysis is you can do filtering, which involves selection of specific data on a stream based on predefined conditions. So an example of this one would be like if you're filtering out log entries that contain errors needed for like immediate attention. You have the ability to aggregation. This involves summarizing or reducing data over a certain time window or key. And then an example of that is calculating the average temperature over the last 10 minutes from my sensor stream. And notice too, the examples that we're giving are like, these are like real-time examples, like data is constantly being ingested and you have the ability to, take actions as this data is coming in. Another cool feature is you have the ability to join streams. So in this demo example, we talk about this specific thing of like joining different streams. So you have the ability to combine data from multiple streams or multiple sources based on a common key or condition. So the example of that is combining user click data with product data to analyze user behavior. And again, like you have the ability to really do these things in real time. Data's coming in, you're running queries on it, transformations, et cetera, and then I'll be able to have some kind of output, which then you can take action on as well. Okay. Some more examples of things you could do in stream processing is you have the ability to do windowing. These queries group data into fixed time intervals or windows for analysis. So an example of that is analyzing the total sales for each hour of the day of the week, over a week. You have the ability to do pattern recognition. I think this one's really cool. You can identify specific sequences or patterns of events in the data stream. So detecting a series of login features as a security breach, that's like an example of one. You might find patterns in like shopping behavior or whatever, and you have the ability to like, take action on this analysis as it comes in real time, which is part of the benefits of it. And then it has stateful processing, which maintains state information to analyze data over time, such as tracking user sessions. And the example of that is like monitoring user behaviors and detecting when a user session is idle. Okay, so data stream processes in RisingWave. So RisingWave accepts data from sources like Kafka, Apache Kinesis, Red Panda, and then materialized CDC sources. And then data can be an output to an external target, such as data warehouses or data lakes for storage or additional processing. So just to kind of dig into this a little bit further, where RisingWave kind of comes in is as you're pulling in data, so you're using a streaming source to ingest events as they're consistently coming in. And then Patrick raised his hand. I don't know if that's a question, but if you have a question, you can also ask in the chat. I don't know if that's an accident, or you're giving me a high five. I don't know. It's one or the other. High five back. So as you're ingesting the data, RisingWave comes in right after the fact. You're able to do processing on that data. All the things that were mentioned, like real-time ingestion. You can join multiple streams. You can join dozens of streams, actually. Filtering, aggregations, transformations, and then continuously updated in queryable states. Like you could do an incremental updated materialized view as well. And then you have the ability to have the downstream side of things as well, which then you can use the RisingWave database, which is like Postgres compatible and SQL. It's all SQL based. That's actually one of the really cool things about RisingWave, and it's one of the reasons why I picked it for this presentation. It's like being able to do stream processing as SQL is amazing. So that's kind of like one of the benefits. So you have the ability to do the downstream side where you can store it in RisingWave or connect it to any other database sources that you want. Data warehouses or data lakes for additional storage processing, depending on what you're doing with the data after you store it. Okay. Never mind. So some example of like stream processing use cases. So as I mentioned, it's like the practice of like continuously extracting, transforming, and moving data among different systems as the data comes in. So RisingWave in specific supports ingesting data from a wide range of data sources. You have the ability to transform the data and do all kinds of transformations, which I kind of mentioned before. And then you have the ability to sync this data to downstream, any kind of downstream system, including RisingWave if you want like the ease of use or quick access to the data afterwards as well. Another example is real-time analytics. I don't know how familiar you guys are with real-time analytics. I've been working in real-time analytics for quite some time now, and I used to think real-time analytics was just being able to get, analytics in real time. And like, I mean, there's some things that make sense, but there's a lot of stuff I think in real-time analytics that are kind of glazed over unless you kind of hyper focus in on like all the capabilities you have with real-time analytics. So real-time analytics essentially is the practice of analyzing data as it's generated or received rather than after the fact. And then, this is kind of like provides businesses with valuable insights and actionable information in near real time. In a lot of industries, it can provide competitive advantage by enabling businesses to respond quickly to changing market conditions and can be used to improve operational efficiency and reduce costs. Just to dig in this a little bit further, because I think some of the things that were surprising to me when I got into real-time analytics and I started understanding the use cases better, is there are things that you can do with real-time analysis that allow you to optimize your user experiences as well. So there's like something called actionable insights, for example. Actionable insights is basically when you take any kind of real-time information that's coming in, and then you make that usable to your end users. And that could be in the form of like a decision-making capability. So like, for example, and this is like, it kind of falls into a gray area, but if somebody like looks at your profile on like LinkedIn or something like that, like you want to be able to see it right away. So a lot of this stuff that comes in is like real-time analysis. Like you have to be able to query those things in real-time speed, be able to show it to your user, and also like, give them the ability to act on that insight. And that's like where the actionable insight comes in. So another example is like maybe grocery delivery app. Your user goes online, they're ordering a bunch of groceries, they get a notification that the supermarket's out of something, and here are like your potential substitutions. Like all those things are like real-time analytics that essentially improves the user experience, the users of your platform, which I think is a really powerful thing. So there's a lot of things that you can do with real-time analytics that aren't super straightforward. Actually, that guy, Zach, I was telling you about, one of the reasons why I asked him to do this, because he's like super, super insightful about a lot of different kinds of use cases. So like, if you have like questions about like something, you have some kind of use cases and you're like, well, where can I put the value in for this? He might be able to help dig into this too. I'm also happy to chat as well. So that's that. Another one is event-driven applications. Again, I don't really know how many people work in like real time or like streaming systems here, but event-driven applications are basically things that are applications that are kind of consistently using streaming data coming in. So as it's mentioned here, it enables continuous event ingestion and processing. And then it maintains context across multiple events and performs sophisticated processing, and also allows you to detect patterns, complex patterns and correlations with a stream of events, which is the stuff that I nerd out about. And then provides direct integration with a variety of upstream and downstream systems, such as Kafka, Postgres, MySQL. Okay, the architecture. So RisingWave is broken down, like I'm talking about the RisingWave architecture for this. So they're broken down into different kind of key components. I think it's pretty straightforward if you're used to like understanding like stream processing architecture. But I'm assuming some of you guys might be new to this. But so first is you have the serving layer. This parses SQL queries and then performs planning and optimizations of query jobs, which is very important for speed and also cost efficiency. Then you have a processing layer, which performs all your computation. That's kind of some of the stuff that I was mentioning before, any of your analysis or queries or any kind of transformations you want to do on the data. And then there's a metadata management services, a service that manages the metadata of different nodes and coordinates operations amongst these nodes. Can't talk today. And this is my second cup of coffee. I should be better. And then you have the storage layer, which stores to and retrieves data from object stores like S3. Okay, so implementing a use case. This is where I'm going to kind of dive into a little bit about this use case. This was actually built by one of the former software engineers at RisingWave. I personally just thought it was really cool when I got to see the app live. Because this data is constantly being refreshed. You have stock data, and then it's using Chat-GPT to kind of give it a little bit of intelligence and context. And what's cool is this was like a hobby kind of demo project that was built, but it actually worked. And I thought that was really interesting. It did do a good job in like determining what's going to happen inside the market, which I thought was pretty cool. Okay, so this is what the dashboard actually looked like. I believe this was like a React app that was built out. But what it showed is how RisingWave manages stream processing jobs for real-time market data by taking into account the stock market values, and then how NLP can enrich the daily tasks with GPT-4. Okay, so I did put the screenshots here for from the actual code from the demo project, but I'm just going to walk you guys all through it one by one. Assuming you already have Kafka stream created, Kafka is a streaming technology. For those who don't know, it allows you to basically take events as they're happening and then stream them into some type of source. So in this case, we're ingesting data with Kafka and connecting that to RisingWave. With this specific code, we created a table accepting market fees. And then we did so by creating a Kafka sync data stream. And I know I mentioned this before, but I'm going to mention it again just because I think this is like part of the coolest part about RisingWave in terms of using this for stream processing, is that it's all SQL based. So when you see this code, it should be pretty straightforward which I'm assuming most of you guys have used SQL. I mean, this is like JCON. So that's my assumption. And I feel like everybody who joins these kinds of online conferences and webinars are constantly looking to advance their fields. So they're usually pretty knowledgeable about this stuff. So the next one is we are creating a materialized view that Windows market feed data. As I mentioned before, RisingWave does enable you to have incremental updates to materialized views. So that's what we did in this specific case. We created a materialized view from the market feed Kafka topic. And then the view is based on a window function, which I think I kind of touched on before, that calculates the average mid price for a 5-minute window. And then the query then groups the data by symbol and then the window start time, and then averages the volume low and high prices for each group. I hope I'm not going too fast because I know there's a lot of stuff kind of pushed into one little screen. So, and then we performed the streaming market statistics in 2 steps. One is we created a materialized view storing the price movement between the 1-hour shifted window and then the volume. And then we calculated the absolute difference between the mid price of the current window and then the mid price of the previous window. And then we grouped the data by symbol and then calculated the move for each group. Oops. Okay. And then we performed the stats aggregations over 24-hour windows. We calculated the standard deviation of the move and volume columns and the window end time. And then we grouped the data by symbol and window end time, and then selected the columns to include in the output. And then the result of that is a materialized view that contains the market statistics for each symbol with window and end time that can be used for like analysis and prediction. Then we performed the streaming outlier detection in 2 steps. One is we created 2 materialized views that filter the symbols based on whether their price movement or trading volume has changed significantly over the last 5 minutes. So this has like a lot of the different kind of like capabilities in terms of like stream processing of like filtering things and, you know, irrigation and stuff. Then we full joined the previous views to get the symbols that either have outlier price movement, trade volume, or both. And then we defined a UDF that takes a stock symbol and an article and then returns some enriched data centered around a stock price indicator score and a 1-sentence justification. And then we created and added the UDFs using RisingWave's Python SDK. And then I guess we probably should have used Java in this case, but the function sends the prompt to the OpenAI API's chat completion model. And then it receives a JSON response that includes a score, confidence, relevance, similarity, justification, explicit mention, and keywords. And then we registered the function to RisingWave. So in this step of the demo, we joined the article metadata stream from a window 1 hour before and 1 hour after each symbol window by creating an enrichment table around market symbols. And that's kind of like what I was showing you before. We created an enrichment table around our market symbols, and then we created a source for our news feed, and then joined our volatile symbols, our keyword enrichment table, and our news feed from 12 hours before and 12 hours after. And that's accounting for market close. Since calling the UDF is not the most cost-efficient thing, we implemented a deduplication responses from previous API invocations that can be retrieved from the RisingWave cluster. So this way we reduce the number of times that we called the API, reducing the overall latency of calling the UDFs. And then finally, we created the real-time streaming output, contained both the enriched data updated in real time and then the historical closed windows. And then this was usually like a movable graph. You can kind of like, you know, wave your mouse over it and it gives you all like the little updates and everything too. It's a super cool demo. I'm kind of upset that it's not like live right now. So with this demo, we achieved the following. One is we did big data analytics. It's complex streaming stats aggregations over potentially 100,000 plus stock symbols. And then we also reduced the cost by doing recomputation of intermediate and final outputs as new streaming data arrives. And then an expensive API calls the Chat-GPT via filtering and caching. And that's it. That's the presentation. So if anybody has any questions, Zach is also here to answer any questions. And then if you have questions for me too, like, you know, feel free to ask. And also, if you want to chat even after the fact, I'm on the RisingWave Slack, so you could chat with me there as well.